In this video, we're going to look at molar mass. So by the end of this, you should be able to calculate the molar mass of any compound with 100% accuracy. But what is molar mass anyways? Well, in the previous lesson, you learned about moles. And the number of grams in a mole of a substance is going to change depending on the substance. And because it changes depending on the substance, we use molar mass to define the mass of that substance. Now, let me give you a quick analogy to help make sense of this. Just like chemical compounds change as we move from substance to substance. So the mass of NaCl is not going to be the same as the mass of a mole of sugar. We can compare that to two animals from the feline family. A house cat is not going to have the same mass as a grown lion. Even though they're both members of the feline family, they'll have very different masses. Just like two different substances are going to have different masses because they're made up of different elements. So the molar mass is just defined as the mass of one mole of a particle of a particular substance. And something to be aware of is that molar mass is also known by the following names: formula weight, formula mass, molecular weight, and molecular mass. So if you see those terms, they're still talking about molar mass. The units for molar mass are always going to be grams per mole, and we abbreviate that G/mol. We're pretty familiar with the periodic table at this point, and if you'll recall, when we look at a particular element, I'm just going to focus in on carbon, we can find the mass of the single element by looking at this number here at the bottom, this decimal number. So the mass of an atom of carbon is 12.011 grams per mole. Now that we know that, let's look at an example. So let's find the molar mass of sulfuric acid, and I've written that for you. It's H2SO4. That's 2 hydrogens, 1 sulfur, and 4 oxygens. So let's look at hydrogen first. Hydrogen's mass is 1.008, but we're just going to go ahead and round all of our masses to the 10th place. So this would be 1.0. 1.0 grams per mole times 2, because I have H2, equals 2.0 grams per mole. Next up is sulfur, and sulfur is going to be 32.1 grams per mole. We only have one sulfur, so it's just 32.1 grams per mole. And finally, oxygen. Again, we're going to round this to the 10th place, so 15.999 would become 16.0. Notice that I have 4 of them, O4, so this is 64.0 grams per mole because 16 times 4 is 64. Now we're going to take these values and add them together. When we do that, we'll find 98.1 grams per mole, which means the molar mass of H2SO4 is 98.1 grams per mole. And don't forget to write your unit. Example 2. Let's find the molar mass of 10,2-hydroxide, which is SnOH2. Recall that when we have parentheses and a number outside of the parentheses, that this number, this 2, is going to get distributed to both elements inside of the parentheses. So I have one 10 atom, 2 oxygens, and 2 hydrogens. Let's start with 10 because it's the first thing written. Okay, we have Sn, and we see that its molar mass is, its atomic mass is 118.7 grams per mole. I only had one 10 atom according to my chemical formula, so it's just 118.7. Next up is oxygen, which, as we saw in the previous example, is 16.0 when we round it to the 10th place. I have 2 of those because my 2 gets distributed to the oxygen, so 32.0 grams per mole. And finally, we have hydrogen, and that's going to be 1 gram per mole times 2 because, again, this 2 is distributed to both elements in the parentheses. So now let's take these 3 values and add them together. And we see that the molar mass of SnOH2 is 152.7 grams per mole. So now you should be able to find the molar mass of a compound Thank y'all for watching.